roots and radicals, rational exponents. All right, rational again is a fancy word for fractions, so we have exponents that are fractions. To note, all properties of exponents apply. The basics of roots and radicals also apply. If we have a to the 1 over n power, so now we are introducing a fraction here as an exponent. A to the 1 over n. The top, the numerator, is the power, the first power, and the bottom, the n, is the root or the index. Okay? So top is the power, bottom is the index. So a to the 1 over n is the nth root of a. So if it was a to the 1/2, that'd be the square root of a. If it was a to the 1/3, that'd be the cube root of the third root of a. Okay, if it was a to the 1/5, it'd be the fifth root of a. A to the m over n equals a to the n. The nth root of a to the m. So again, the top number is the power, m. In this case, this was 1 right over here. But we're not talking about 1 anymore. We're talking about some other power, m. And n is the root. So again, when you have a fraction for an exponent, the top, the numerator of that fraction is the power, and the bottom is the root or the index. All right? So another way that it can be written, a to the m over n, is the nth root of a in parentheses, all to the m power. Okay? So when I look at this one, if I am actually calculating numbers, I'm going to use that, because inside my parentheses, what am I doing? I'm making my a smaller by taking the root and then applying the power to it. If you go in this order up here, you do this first, a to the m, you're making it bigger and then taking the root. You can figure it out. It may be just fine. And if you have a calculator, it really doesn't matter. Okay? But if you don't have a calculator or whatnot, or if you're just trying to think through it, it's a lot easier to make it smaller if that's possible before you make it bigger. Okay? So this is more of the way I think about it right here, especially when I'm calculating it on my own or without a calculator or whatnot. All right? Make it smaller and then bigger. All right? And then a to the negative m over n, it does not mean flip this. It means take the entire thing and move it to the bottom, or the denominator, just like it does when we have negative exponents. Remember, that's all the properties of exponents apply. Negative exponent means move the entire thing to the denominator and change the exponent from negative to positive. The m over n is still m over n. It just goes from negative to positive when you move it across the fraction line. Okay? So I have a video, Properties of Exponents, negative exponents, that talks about that property right there. All right? So let's look at some of these. First of all, let's simply write as a rational exponent, but don't simplify it. So I literally want you to take it and go from this form over here to this form right here. Okay? So remember, the root is the bottom, the denominator, and the power is the top or the numerator. So the square root of 17, it's understood to be the first power and the second root. Right? So this is going to be 17, and it's a fraction. The power over the root. The power is 1, the root's 2. So 17 to the 1/2. Don't simplify. You can't simplify that, but not without a calculator, but don't do that. The cube root of 6, again, understood to be 1. So this is going to be 6 to the power over the root. The power is 1 over the root is 3. 6 to the 1/3 power. All right? And then the square root of d to the 5th. Again, there's understood to be something here. Understood to be a 2 here, right? So then it's going to be d with a fraction. It's going to be the power over the root. 5 over 2. D to the 5/2. All right, down here to the 7th root of p to the 4th. It's the p to the what? The power 4 over the root 7. Now I want you to notice something. Halfway up my p right here, I draw a line through there. My 4/7 is above it. Don't do this. That's not a power. Powers and exponents are what? They are raised up. So this p and this are not in relation to each other good enough for that to be a power. So you want to make sure that if I draw a line halfway through whatever I have, that thing is above it. Okay? And since this is a lowercase p, it needs to be halfway through that p right there and above it. All right? So things to watch out for there. All right, the next one is a little bit tricky. Xy to the 5th to the 7th, or the 7th root of xy to the 5th. What's being raised to the 5th power here? That's right, only the y. The x is not raised. So if you simply, this is wrong, okay? X, y to the 5/7. You completely forgot about the x. That's bad. That's wrong. No good. All right? So what we want to do is we have more than one factor raised to a power here. We're going to put all that in parentheses. If it's more than one factor or more than one term, put it in parentheses, and this whole thing is to the first power, right? So then that means it's going to be to the 1/7. When you have more than one factor, the whole thing is to the 1 whatever. So the next one is exactly the same way because you have a 2 and then you have x to the third. It's like this is in parentheses to the first power. So this is going to be 2x to the third, all in parentheses, to the 1/4 power. You can't put 2x to the 3/4 because then you completely forgot about the 4 being, the 2 being to the 4th root, or having the 4th root taken of the 2 there. All right, so let's keep looking at some more of these. Actually, let's now change it, write it as a radical, and now we want to simplify it. We're going to go the other direction. So the top's the power, the bottom's the root. So this is going to be the square root of 100 to the first power. We don't write the 2 and the 1 there, right? But that's what it is. Square root, understood 2, 100 to the first power. And if we simplify that, the square root of 100 is simply what? 10. 10. And then here, negative 27 to the 1/3. That means we're going to have the cube root. That's the bottom. This is the root, right? The index. The cube root of negative 27 to the what power? First, but we don't write that way, right? If it's first power, we just write the number down. It's understood to be the first. So can I have a cube root of a negative? Yes, it's an even root. If that 3, that cube root was an even number like square root 2 or 4th root or something, we couldn't do this. But odd roots of negative numbers are simply negative. This is negative. The cube root of 27 is 3. So the answer is simply negative 3. Negative 3. And that negative, look, this negative 27 is all under the radical because this negative 27 is in what? Parentheses. So the 1/3 power was applied to all of the negative 27 as opposed to the next problem. The next problem is a negative sign out front, and then we have the 4th root of 16, and we don't write that 1, first power, okay? Why is the negative not under the radical this time? Because this is not in parentheses. This order of operations, do the exponent before you multiply by the number out front, okay? So this is going to be negative, and the 4th root of 16 is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, right? 2 multiplied by itself 4 times, or 4 2's multiplied together is 16, I should say. All right? So what about 7 to the 3/2 power? All right? 7 to the 3/2 power. So if we rewrite this, this is going to be the square root of 7 cubed. And I really can't, so I'm just going to rewrite this as the square root of 7 cubed. Either way, probably should have written it that way to begin with. 7 cubed is 343, and there's no perfect square inside there, so it doesn't have to come out to something like the other ones. Okay? We can still cube the 7. I just couldn't make the 7 smaller this time, right? I couldn't take the square root of 7 and find it. So I said, well, let me write it the other way. The square root of 7 cubed. So then 7 cubed is 343. And I cannot do anything with that. That doesn't factor into 4, 9, 16, nothing like that to simplify anymore. Okay? So the square root of 343 is just all that is to it. Okay? So then 27 to the 4/3. This means what? The cube root of 27 and then raised to the 4th power. This time I can calculate the cube root of 27, right? Which is 3 and raise it to the 4th power, which is going to be 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay? So 3 to the 4th is 81. That's one of those numbers I said you should file away in your memory banks and know. And then negative 32 to the 3/5. So this is going to be the 5th root of negative 32. And why is negative 32 under the radical? Because this is in parentheses, right? It's all under the radical. And that whole thing is raised to the what power? 3rd. You can do it a different way, but again, I like to make it smaller if I can. I just couldn't make this one over here smaller, so I had to go to this method, right? So negative, let's see. 5th root of a negative is going to be negative. And what do you multiply by itself 5 times to get 32? Again, this is one I told you to remember. 2 to the 5th is 32. So the 5th root of 32 is 2. So this is negative 2, still in parentheses, to the 3rd power. That means I take negative 2 times negative 2, which is 4, times a 3rd negative 2. So 4 times negative 2 is negative 8. negative 8. So this final answer is negative 8. All right? So all of these simplified to something outside a radical except this one, right? But I wanted to show you that sometimes it doesn't. Sometimes you can cube the 7, but then you can't take the square root of it, or you can't take whatever root it happens to be there of that number. All right? Well, here's some more of the rules, right? Now we're going to do some negative, right? This is just the same thing with negatives. This just means take this whole thing and put it down, right? If it were over 1, move the whole thing into the denominator, 64 to the 1/2 power, and then if you move everything from the top, the numerator, there's a 1 still up there, right? And again, don't write this. What's wrong with that? This is a power. It's got to be raised, okay? That way I wrote it just then was not raised. I point that out because I've been teaching for over 2 decades, and I get lots of those, okay? And tutored for a decade before that. So I got 3 decades of experience helping people with math, right? So here, this then means 1 over the square root of 64, which is 1 over 8. And you can't do anything else with that. 1 over 8, and it is simplified at this point. 1 over 8. So then 8 to the negative 1/3. Again, we take this whole thing and we move it down, right? It's over 1, so we're going to move everything off the top of the numerator. So it's 1 over 8 to the 1/3, which really means 1 over the cube root of 8, right? 8 to the first power is 8. And the cube root of 8 is what? 2. So that's just simply 1/2. That simplifies to 1/2. All right, so now we're going to take this whole thing, because this is in parentheses, the whole thing's being raised to the negative power. We're going to move it to the bottom or denominator, right? It's over 1, so this is going to become 1 over negative 27, and this is still in parentheses because the whole 2/3 power is applied to all of that. That 2/3 power is applied to everything in the parentheses. It just now is a positive 2/3 because I moved it across the fraction line. I moved it from the top, the numerator, to the bottom, the denominator. So this is then going to become 1 over the cube root of, and the negative 27 is under here, right? Because it's in parentheses, all to the what power? Second. What is the cube root of negative 27? Remember, the cube root of a negative is negative. Cube root of 27 is 3. So we're going to do 1 over negative 3 squared. So I'm going to erase that a little bit and then center my 1 up to make it look a little better, right? So that's going to be 1 over, and negative 3 times negative 3 is a positive 9. So that turns into 1/9. All right? That becomes 1/9. All right. So let's look at, oh boy, x to the 2/3 times x to the 1/2. What does the rule say whenever you multiply like bases? Right? Again, this is all those properties of exponents hold true here, right? So properties of exponents here, when you multiply like bases, you add the exponents, and it's no different here. It's going to be x to the 2/3 plus 1/2, okay? X to the 2/3 plus 1/2. Now I go to a different part of math, right? Everything you've ever learned, right, is always fair game in math. That's the way math works. So at some point in your math life, you're supposed to know how to add 2 fractions. You have to get a common denominator, right? So look, I don't like dealing with 2 fractions in an exponent trying to get a common denominator. So here's another use where I like thought clouds, all right? If this is the first time you've seen one of my videos and I talk about thought clouds help you when you're working part of a problem and you're not done, or it's not equal to it, or something, or just to remind me, hey, I'm not finished with the problem. This is just a piece of it, but I don't really want to write the whole thing down over and over and over again. So what I'm going to do is come down here and put equals x, and I'm going to put some question marks here because I want to know what is this thing simplify into. So what I'm going to do is I'm going to come over here and figure out what my power is, okay? Figure out what my power is over here in the thought cloud. Okay? That's not what I wanted to do. Okay, we're going to come over here in a thought cloud, right? And I'm going to have 2/3 plus 1/2. And I skipped a little space there on purpose, all right? What is my LCD when I look at this? My LCD is 6, right? 3 and 2 is going to be 6. So then I need to figure out what do I multiply by each fraction so that I get 6 down here, right? So 3 times 2, and whatever I put in the bottom, I got to put in the top, right? Numerator and denominator, because 2 over 2 is 1. Don't go crossing those out. That defeats the purpose. Go ahead and multiply them together. 4 over 6, right? Plus, what do you multiply here to get 6? Well, 2 times 3, and whatever you put in the denominator, you got to put in the numerator. Again, don't cross those out and multiply them. It's going to be 3 over 6. That's going to give me 4 plus 3 over 6. The whole reason we get a common denominator is so that we can combine the numerators, add or subtract, whatever happens, and then keep the denominator the same. Don't do 6 and 6 is 12. So that becomes 7 over 6. Can I simplify that? No. That's not my answer, but that now becomes this. That's what my question marks are over here, right? So I'm going to come over here and erase this and then bring back what I just did here. I'm going to take this and bring it back over here and say this is going to be 7/6 power. So x to the 7/6 power is what it is when you take x to the 2/3 times x to the 1/2. When you add these exponents, you get 7/6. And I did that over here in a thought cloud. Okay? So the next one, w to the 5/9 power over w to the 1/9 power. How on earth do I divide like bases? Well, I subtract. And look, the way I teach this, if you go back and watch my properties of exponents videos, I teach you to say, hey, do the bigger minus the smaller and then leave them left over, like if the highest power's in the bottom, leave it left in the bottom, the denominator. But here with fractions, you could look at this one and you probably know which one is larger. You know 5/9 is bigger than 1/9. However, sometimes it's not so obvious with fractions, so what I teach my students is just subtract the numerator, the top, minus the denominator, the bottom, and then once I get my common denominator and subtract them, if I get a negative exponent, guess what? I'll just put it in the bottom or denominator, okay? So here, I'm going to treat this the same way. I'm going to do this as w to the 5/9 minus 1/9, and here something very glorious happens. I already have a common denominator. I don't have to go do a thought cloud and figure all that out. This is literally w to the 5 minus 1 over 9, which is w to the what? 4/9. And I'm done. There's nothing else to do to that one. W to the 4/9. Okay? W to the 4/9. That's a pretty ugly 9. Sorry, 9. But you are pretty ugly. All right, here we are dividing again. Here we have x to the 1/4 divided by x to the 3/5. And again, some of you will look at this and go, oh, 3/5 is bigger. Let me do the 3/5 minus 1/4 and keep it in the bottom. If you don't see that or don't know that, that's okay. And what if that's not even right? What if you do that? So I'm just going to do the top 1/4 minus the bottom, the denominator 3/5. And then if I get a negative exponent, I'll put it in the denominator. So I'm going to come down here and say, okay, this should be x to the 1/4, not should be, it is, minus 3/5. And that's going to come down here and be x to the something. All right, what is my something here that I get? Okay, well, let's come out here in a thought cloud and figure out what this is. I got plenty of room for a big thought cloud here. All right, there's my thought cloud. So I have 1/4 minus 3/5, and I always leave some space here so I can come back and multiply by to get my LCD. What is my LCD in this case? My LCD is going to be 20, right? So then what do I multiply by this one to get 20 down here? 5, right? 5 over 5. And if I multiply, that's 5 over 20, right? Minus, here, what do I multiply by, right? Because 5 is not the same thing as 20. That tells me I have to multiply by something, and it is 4. So put 4 over 4. So that gives me 3 times 4 is 12 over 5 times 4 is 20. And then I end up with 5 minus 12 over 20, which is negative 7 over 20. And I take that, and I bring it right back over here into this spot right here, okay? So let me erase those and put in here negative 7 over 20. And typically speaking, okay, our book or our teacher, somebody says, hey, look, simplify these things, but do it with positive exponents only. We typically don't leave negative exponents in anything, all right, except scientific notation. So here I'm going to take this whole thing, and it's like it's over 1, and I'm going to move it where? To the denominator of the bottom. So it's going to be x to the 7. You got to make sure that's raised and looks like a power. Don't write the 7/20ths by the x. Make sure it's at least halfway up the x. And you got a good marker on x. It's where the things cross right here, right? It needs to be clearly above that. All right, that level. And then everything got moved off the numerator at the top, so there's a 1 left over. So 1 over x to the 7/20ths power. All right. So that one was kind of long and difficult, but it wasn't that much worse than the first one we did where we had 2/3 plus 1/2. It's just a subtraction. It's a fraction. It looked worse. All right. So let's look at these here. 2 to the 4/5 power to the 5th power. Well, when you raise a power to a power, what is that rule? This is more properties of exponents, right? We multiply the powers. This is 2 to the 4/5 times 5. Well, I'm going to remind myself that 5 is really over what? 1. These 5s divide out, and I'm left with 2 to the 4th power, right? And 2 to the 4th power is 16. Okay? So the big idea here is a power, a power to a power means multiply the exponents. So 2y to the 1/4, all to the 4th power for the next one. Here, see on this one we had one factor. Here we have 2 and we have y. We have 2 factors. Anytime you have multiple factors raised to a power, as long as it's one term, if this was 2 plus, you couldn't do this, but it's not. We can take the 2 to the 4th power and the y to the 1/4 to the 4th power. Okay? That's how we do powers to powers. All right? That's how we do multiple factors to a power. We take each factor and raise it to that power. But powers to powers, that's what we're going to do here, multiply them, okay? So here, 2 to the 4th power is 16, we just saw that. And then here, y to the 1/4 times 4. But wait a minute. This 4 is really over 1. Those divide out, and we're left with 16y, and then 1 over 1 is just 1. So that's just 16y to the 1st power, which is 16y. 16y to the 1st power, which is just good old 16y. All right, let's see what else we have here. And again, typically I go through and get rid of negative exponents first, but when I have a exponent to an exponent or power to a power, I'm multiplying those. I'm going to go ahead and do that multiplication and simplify it, and then again, if I end up with a negative, I'll just move it at that point. If it's in the bottom, move it up to the top from denominator to numerator. If it's in the numerator in the top, move it to the bottom of the denominator, okay? So here, I'm going to say this is going to be m to the negative force times 1/6. All right, so then what do I do now? Well, take this and I say, okay, this 3 can become a 1, and that's a 2 because 3 goes into those two things, right? So this becomes m to the negative 1 times 1 is 1 over 4 times 2 is 8. And then I have that negative exponent, right? So that means I'm going to take this whole thing and move it to the bottom or denominator, right? Because it's all over 1. I shouldn't just put the m, it's all over it. So that's going to end up becoming m to the 1/8, and this is a 1 up here, right? This next one, there's actually a couple of ways you can do this. This is all one term, so I can apply the 1/3 power to the 125. I can apply the 1/3 power to the v to the 12th and the 1/3 power to this one, okay? I can do that if I would like, right? The other way that I can do this is go, oh, wait, 1/3 power means this is the cube root of all of this, right? So I can do that way. So I guess I'll work this one both ways. We'll say this is going to be 125 to the 1/3, v to the 12th to the 1/3, and then p to the 3rd to the 3rd. And then what does it mean? Well, it means this. It means, let's see, this first one, when it's a number, I'm definitely going to be like, okay, wait a minute. That is the cube root of 125. And here this is v to the 12 times 1/3, and p to the 3 times 1/3, all right? And then I'm going to remind myself, oh, wait a minute, this is over 1, right? So that becomes a 4, and that becomes a 1, all right? So this is v to the 4th and p to the 1st power, and the cube root of 125 is just 5. So 5 v to the 4th p is our final answer there. Now what if I said, okay, let me go back and look at this by the other method I said, or I could have said this is the cube root of 125 v to the 12th p to the 3rd, right? So I say, okay, well, how do I do that? Well, the cube root of 125 is what? 5. How many times does 3 go into 12? 4 times. So that's v to the 4th with how many left over? None. There's none left under the radical right now. 3 goes into 3 how many times? 1 time. That's where I get the p to the 1st with nothing left over. So it doesn't matter which way I do this. We get the same answer there. All right? So I hope that these rational exponents, fractions and the exponents, don't give you too much trouble. Okay, I know nobody likes fractions. All right, but hopefully this helped explain them somewhat. Remember, the top is the power, the numerator of the fraction, and the exponent's the power. The bottom number, the denominator, is the root or the index. All right?